introductions. Thanks. And without further ado, I'll move on in the agenda because we just lost a few moments there. Excuse me. So what I'm going to cover is a little bit about the technology and the Rajant story, just to give you a sense of how we position this in the marketplace and the types of use cases that are ideally suited to Rajant technology. And then I'm going to talk about three areas that should be of interest in the region, which is rapid deployment, emergency care, but equally rapid deployment of any situation. Something about public safety act, part of Rajant's business, you should be of interest. My partners, questions about Rajant. Rajant actually emerged from the events of 9/11 in New York, after which the Department of Homeland Security launched a program to find what they called an expeditious deployed network with no single point of failure. Because during the events of that day in September 2001, the emergency services communications were largely routed to a mast on top of one of the Twin Towers. So as soon as that mast came down, their communication was compromised, and therefore it led to some responses based on analog legacy radio systems. So the difference that Rajant emerged from that study and some investment by the founders was that it moved away from an infrastructure-based communication system and a reliance upon masts and coverage provided at a distance. And so what it was developed to address was mission-critical communications with low latency and high performance, but also military spec security. And you combine that into a mobile environment, and that's extraordinarily difficult. So you can see on the right here some of the industries that we are embedded within and exploring as we go along. And I'll cover some of these in this discussion now. But what I would stress is that if you have opportunities in any of these areas, please come and speak to us. I can't cover all of it in one webinar. So the difference about Rajant in terms of the technology, we talk about it bringing wireless networks to life. Our technology never drops to move around the network. It maintains multiple connections simultaneously across multiple frequencies, and therefore the handover is seamless. We don't drop packets, we don't drop a connection and then re-establish a connection. And this can even happen at high speeds. We've got examples of connectivity with streaming video without dropping packets at 135 miles an hour. Because we're using multiple frequencies and because all nodes communicate with all other nodes, it mitigates against interference. So this protocol that we call InstaMesh is evaluating every route that's available to it to pass traffic and identifies the best route based on latency, based on the RF environment, and based on getting that packet off the wireless network as quickly as possible. It's all via layer 2. And this gives you full redundancy. We don't have to get to a switch or a controller. Every node performs that switching functionality. So that means that because that protocol is distributed, there is no single point of failure. So there is no route or LAN controller or switch. If one node fails or is powered down, it has minimal impact on the rest of the mesh. And finally, it's highly scalable. Not only can we build very large meshes, our largest to date is 503 nodes, but we can also include a number of network egress points to make sure that we're getting high bandwidth off the mesh really quickly without introducing loops into the network. So those of you from a technical perspective, that's extremely important. So the technology allows us to address these types of use cases. So mission critical reliability, where you can't do the job without connectivity. And we'll see some examples of that in a minute. Every RF environment is different, and as you move around, and our solutions are really well tailored towards mobility, that changes, as does the environment in which you're working. So it has to do autonomous adaptability. Continuous connectivity, and you'll see some of the examples of this. Some of the use cases where Rajant is particularly strong require that you do not drop a single packet in the connectivity for safety purposes. And finally, as more businesses are mining the data as well as materials, but mining the data that they generate in the course of their business, they can make real-time decisions on process control and efficiencies only if you're continually connected. So these breadcrumbs, as we call them, are not just radios. They're intelligent network nodes, and they actually perform at layer 2, and I can't underline that more strongly. They provide functions at layer 2 that you would normally see at layer 3. So they switch, they route. You can tag VLANs to direct the traffic to appropriate nodes and exclude other nodes. They can act as gateways to extend the network, or bridges to further route messages onto wired networks, microwave links, satellite links, point-to-point. So extremely flexible in the onward transmission of data. And finally, in order to facilitate client devices that need to connect to the network, our breadcrumbs can be configured to broadcast SSIDs to allow Wi-Fi clients to access that mesh network. So this is a picture of a non-Rajant network. This is a traditional Wi-Fi mesh network where you have a series of access points operating and connecting on one frequency, and a series of client devices connecting to those access points on a separate frequency. The client nodes do not communicate with each other. So if that access point fails, all of the nodes, the clients connected to that node, will not have communications. Added to which, it needs to get back to a controller. It isn't very scalable. As you add more network access points, you need to add more controllers, and you lose bandwidth as it transmits across the mesh. It's not a true mesh in our sense of the word mesh. A Rajant mesh, you can see here, every node talks to virtually every other node as long as it can connect. Doesn't require a controller, has changes as your movement changes around the network. Very easy to deploy, because once the network nodes are configured, you power them up and they establish the connection. It has robust security and is a much more flexible way of providing communications. And just to underline the point, this is a dual frequency network. All nodes are transmitting and receiving on both frequencies simultaneously, and therefore you get the effectively full duplex communications and you don't lose bandwidth. Just a final point about latency. Because this network protocol InstaMesh is distributed, our latency is very low because those nodes themselves are making the routing decisions. So we typically get between 1 and 2 milliseconds per network hop on the wireless environment in terms of latency, which, as we'll see a bit later on, for autonomy, etc., is extremely important. So in order to mesh, the breadcrumbs have got to share that channel, the network name and network key, both of which gives you a security function. But then we have advanced cryptographic settings such as packet cipher, MAC address cipher, per hop authentication, and key sequence number. An incredibly secure network based around our heritage in the US military. So these are the types of security functions that we're able to add to the breadcrumb system. That means that it can be used not only for sensitive communications from a commercial perspective, but is protected against criminal or terrorist interference in what can be some dangerous activities, and I'll come on to those in a little while. The breadcrumb product family all fulfill the same function. In other words, they route data in exactly the same way. The only difference between these breadcrumb models is their form factor, their environment in which they should be deployed, and the cost. Because as you can imagine, to make, for example, the top left LX5 series IP67 mil standard 810G, resistant to dust, resistant to water, and capable of being mounted on moving equipment in a mining or a military environment. That's a high cost unit, whereas the ES1 down at the bottom middle is designed for static deployments, still IP67, but it's not robust enough to handle things like mining or military vehicles, and so therefore it can be used for public safety environments. And you see the DX2 bottom right, very light, very quick MIMO single radio unit, largely developed for autonomous vehicles or person wearing. So lots of different functionalities, and I'll happily work through with you some of these more interesting applications of these devices. So the first example I just want to give you is something that is very current at the moment, particularly in the States and Europe, where due to coronavirus, field hospitals are effectively being established, and those field hospitals are frequently in environments that don't have connectivity. So one of the examples of a Rajant deployment in healthcare is to provide connectivity to those rapidly established triage and treatment centers. And in modern medicine, most of the machinery dealing with people in intensive care and highly infectious environments have continuous monitoring that needs to be transmitted back to a central database to update records, to retrieve patient information, and to order medication, etc. And we can provide this and have done so. I'll show you some examples of this, but this is just one example where the triage center is next to the hospital. And so it's entirely catered for by a deployment of Breadcrumbs. This second example, the triage quarantine area can be seen is some distance from the hospital because of availability of space, availability of location. And in this case, you have a breadcrumb network providing the local connectivity, not only for the machines, but for devices that the medical personnel are using, such as tablets and cell phones, smartphones. But because of that layer 2 connectivity that I mentioned before, here we have a point-to-point link between the hospital and the first breadcrumb in the network. And that means you just plug into the Ethernet port, and because it's operating at layer 2, it's a seamless gateway to allow you to do that backhaul to the hospital. So that's another example. A third healthcare example is where there is a premises some distance in, for example, a sports stadium or a school. The network is provided internally, locally, and then you can link to a land-based network, which is the buildings network that will allow transmission back to the hospital. So again, you can see the Ethernet port on that ES1 white model on the right. It's just like plugging into a LAN socket in the wall in your office. So very flexible, very quick to deploy, secure, can even be run on batteries if you need to, if you don't have access to power for rapid deployment. So that's just another example of Rajant in the healthcare environment. And this is a real deployment in Pennsylvania. They turned a school into a federal medical station because the capacity in the local hospital was being overwhelmed at the time. And they needed to make sure that they could get that connectivity and utilize the space to deal with the patients. And you can see there the military's involved. There's a Rajant gentleman on the left putting up a breadcrumb on a mast. Those masts then getting deployed both inside and outside. And it's remarkable how quickly you can set up a Rajant network. If I go to a conference or an exhibition, I usually take a 4 or 5 node Rajant network and can have that set up in less than an hour in terms of opening the box to when the network is passing traffic. It's a case of bolting them to a tripod, powering them up, and they will pass data. So just from a medical perspective, that's one of the deployment use cases that we see. But bear in mind that this could be a police incident, it could be an accident, it could be a military operation, It could be any scenario or event that requires very rapid, high bandwidth communication in environments that have no infrastructure. So very, very flexible in terms of being able to deploy for a multitude of purposes. This happens to be medical. Public safety. This is another increasing application of Rajant networks where both mobile and static nodes are used either as permanent fixtures or installed in response to activities. And of course, because we have high bandwidth, low latency, not only can we support things like GPS location, personnel tracking, and vehicle telemetry, what we can support is CCTV because of high bandwidth, low latency, and that can either be on fixed network nodes, permanently installed, or on vehicles, or handheld cameras and body-worn becoming increasingly utilized. And I have an example of a body-worn implementation by one of our technology partners. So the public safety aspect of a Rajant network it's really critical. These people are not network experts. They also have an existing investment in communication infrastructure. So you have to make sure that whatever you're providing gives you that integration. The simplicity of setup, it just has to be quick to deploy and easy to operate. I'll give you an example of how easy this is to operate in a second when I talk about the experiences of the UK police. So where we really play well is either putting connectivity in where it doesn't exist or augmenting what already exists, again, because of that integration. We can go beyond CCTV. There are some examples, including acoustic sensors triangulating on gunfire in order to dispatch people to where guns have been discharged in urban environments, or thermal imaging on drones to look for people, targets, etc. Again, I've got some examples of where we used this with the UK Royal Marines, looking for a pilot that had been shot down in a remote environment using the thermal signature of his body. Provides continuous mission critical data, situational awareness, and again, there is no single point of failure. If you take one of these nodes out, the rest of them adapt instantly to the requirements to pass communication and data. So here's an example of where in the UK our data was used in a live environment. So the serious organised crime units of the UK have what they call technical surveillance units, and they do both overt and covert surveillance in support of public safety, security operations, etc. And they approached Rajant with regard to one particular event for which they required our help. So there were three events that this organisation, the Southeast Technical Surveillance Unit, wanted to cover. One were the two weddings, royal weddings of Prince Harry and Princess Eugenie, and the Royal Ascot race meeting. Now, in all of these three cases, they wanted to implement CCTV coverage where no infrastructure existed before. And they had very short notice to do so, and traditional mechanisms of communicating suffered from problems with line of sight, with connectivity, and with throughput. And so this technical surveillance unit approached us. The first one was Prince Harry and Meghan Markle. And we only had, I mean, it sounds like a long time, but we only had 6 weeks notice. And then for deployment, we only got access to the locality on the Monday before the wedding. And the final network location to mount our node was provided on the Thursday evening before the wedding. So we only had Friday to configure and make sure that the system worked. And so what we were doing was providing security cameras along the roads. We had that 2 months, slightly less than 2 months to hit that non-movable delivery. And we also had to integrate with the police and the security services in terms of imagery. Now, you can imagine the number of smartphones with 2.4 and 5 gig frequencies bouncing around this environment, hundreds of thousands of people, scores of international media companies, all of whom were bringing their radio devices to communicate. You can even see one on the top of a mast to the right there. And so what we were doing was putting in place IP cameras that had to be secure, had to be reliable, and had to be in situations where there was no infrastructure. So we worked with Thames Valley Police. We flew a guy over to help them configure, but largely they were able to manage and configure the system themselves. And so this is the solution that we deployed. You can see the diagram on the right, which is just giving you a sense of the shots of where we were sending the data with the antennas that we used. We blanketed the area, and we had an excellent result. So much so that they told us that our solution was 2 to 3 seconds quicker than the BBC, who are covering the same event. We had an integrated solution passing data not only locally, but out to security forces and special forces who are on standby. But particularly here, they were so impressed that we now have a Rajant breadcrumb permanently installed on the top of Windsor Castle, which is used now for regular events, such that the police deploy. Now, an important point here, we haven't trained the police. We worked with them for a few days, but they have been able to take their own radio experience and actually utilize our network on multiple events without any further involvement from Rajant, and are recommending it to other police forces. So it was chosen for 4 key reasons. And again, these are some of those guiding principles that if you have opportunities like this that you have in your region, it's a very strong use case. So speed and ease of deployment. In some cases, we had a cherry picker with a battery that provided them with coverage instantly in an environment that didn't have even power, let alone network connectivity. Highly secure up to military grade, as we mentioned. That interconnection leverages legacy investment in networks, which is a really important point. Excuse me. And specifically here, and I don't know whether this is available in your region, but one of the frequencies was 4.9 gigahertz, which meant that we avoided that interference from the public. So here's an example of a technology partner called Vorbeck. And Vorbeck's speciality is graphene antennas. So built into that vest there, into the very fabric of the vest, is a series of graphene antennas that previously featured ES1 that we saw before, the lightweight, non-ruggedized Rajant breadcrumb, still with 2.4 and 5.8 gig connectivity, has been integrated into this vest with a media hub, a video, and a push-to-talk capability over the microphone that actually allows that vest to become a network node and to take coverage into environments that might not have it currently, that could be, as you can see examples here, tunnels, factories, dams, but also any event that requires connectivity and situational awareness to be transmitted back. So this Vorbeck vest is an incredibly compact way of extending networks into difficult environments. And it's just an example about how our technology can be integrated into other solutions for customers. And I'll come on to that again as I talk about other use cases. So ports. Now, this is a really interesting area of Rajant's business that has become increasingly important. And we have, the logistics world is one that relies upon systems and services to handle goods really efficiently, as little as possible. And so they're always looking for increased efficiency across their operations. And they want to get to increased profitability because there are slim margins in the logistics business, but if you do the job right regularly, you can earn a lot of money, as you can see by the emergence of some of the larger container port operators around the world. So what they're looking for is all of these 3 increases in financial and efficiency, but they have to improve safety. The overriding feature of all industrial network environments is that firstly, they operate 24/7, But secondly, if something untoward happens and they have an accident, they have to stop. They have to stop to address the situation. They also have to stop to investigate what happened and make reports to the governing authorities, because typically or incidents involve either damage or injury or worse, even death. And that's a really important aspect to any of these operational industrial environments. So whatever solution you deploy has to make sure that you have improved safety. So what is happening in ports? So the operational realities of ports are that they're complex, big infrastructures. There are lots of different networks meeting different needs. There's a large, constantly moving volume of containers that they themselves create obstacles. There are security concerns. These are ports of entry into the country, so they're targets for criminals and for terrorists because they can be vulnerable because of that nature of the trade that they're transitioning. And they're on the typically seaports are on the coast, and so they are subject to extreme weather, whether that be temperature, rain, humidity, dust, etc. So your solutions have to be weather resistant. And there is that need for real-time information to direct the flow of goods, personnel, and vehicles. Traditional infrastructure that is fixed tends to be out of date very quickly because ports are live environments. They move, they change, and they are not feasible to build out fiber in these environments because you have to suspend operations if you're digging up the port. Finally, you're meeting continuous changing needs to move that cargo on and off the ships in different locations, in different environments. And you have a multitude of different users who are both employed by the port and not employed by the port. Excuse me. So what's happening with autonomy? Well, the very first thing is that on vehicles and cranes and assets, what's being put in place is GPS, is videos, and of course, a link to the terminal operating system. And of course, in this environment, you can see the amount of metal involved. You can see the fact that there is a person on each of these pieces of equipment, and there are people and applications back at the port office, which is up towards the top left. And as a part of the move towards automation, this is the first step. And what you find is that this becomes a way of knowing where your assets are, what they're doing, to instruct them, and to get feeds from that device whilst the person is still operating. Where they're going with autonomy is towards what's called tele-remote operation of the gantry cranes, tele-remote operation of the quayside container cranes. In other words, a person in an office with a joystick doing the job across multiple cranes rather than having a person in each of those cranes. And then moving towards autonomous, fully autonomous or tele-remote container handling equipment, such as that terminal tractor that you see bottom left. No driver, fully autonomous, controlled, but has to have situational awareness for that overriding safety functionality. So when you take people out of these environments, you put them in a different location, but you still have to get the data from those devices to that person. So what happens is all of the people that are on those devices go into your control center. And part of the efficiency is that you reduce the amount of people. A good example, one of those RTGs in the center of the picture may be idle for up to 20–30% of the day because the container destined for that stack only comes in according to the stacking regulations, the stacking instructions coming from the terminal operating system. If there's no container for that stack, the driver is sat in that largely reading a newspaper and costing them money. So that's why they're taking people out of this equation. But that means that the communication between those assets and the application and the people in the office becomes ever more important. So the solution, we believe, is to blanket that with a mesh network connecting all nodes to every other node, allowing communication in the stacks, between the stacks, above the stacks, and making sure that all of the devices communicate where they are, what they're doing, how they're performing, the condition, and making sure that they avoid each other and maintain all those safety rules and configurations. A prime example is local to the United Arab Emirates. This is one of our partners who has secured a contract that was announced last week, beg your pardon, with DP World. And what they're deploying initially at Jebel Ali Terminal 3 is 150 fully autonomous in-terminal vehicles to move those containers around. So this is an example of the pilot that was performed. And if you look closely above the cab of that vehicle where a driver would normally sit, you have a GPS antenna to the left, and then you have 4 vertical white antennas, and those are Rajant radios. Now, the reason why you need Rajant radios or communications on autonomous solutions is because of exception handling and where things don't go completely to plan, or you need to take control for various reasons. And if you need to do so, you need a network that supports high bandwidth to see the cameras, to allow the remote driver to see where that truck is heading. You need to have location from the GPS to be absolutely certain where it is. But actually you need that low latency, because if for any reason that vehicle has to stop with the remote operator, you want it to stop in milliseconds rather than there be any delay that would either send it into another piece of equipment, another person, or conceivably off the edge of the quay. So high bandwidth, low latency, a real example. And DP World just announced that they're not only thinking just of Terminal 3, they're going to expand it to the other terminals as well. So it's entirely possible that in the next couple of years, there could be anything up to 1,000 terminal tractors operating in that environment, using autonomy but controlled by Rajant radios. Okay, that was 3 use cases. I want to just quickly go through how we go to market. Rajant is a manufacturer, and as a manufacturer, we rely upon a channel model to go to market. So we appoint distributors in different geographies, Minerva being one of those in the United Arab Emirates, but dealing with largely GCC states. Other distributors cover different geographies. Each of those distributors has a series of resellers or integration partners with whom they deal. And those are the people who have the relationship with the end customer. So Rajant only sells direct to US military and 1 or 2 other key sensitive military customers. The rest of the time, we go through our partners and we will support you to win business with those end customers as part of that continuum in the channel model. So we work with OEMs to get our equipment certified for use on their equipment. We're working with crane operators, with mining vehicle operators, with automation companies that allow them to state that our networks will support their solutions. And there's an ecosystem around that as well. You saw one example of that with Vorbeck, who produce that vest. We have another antenna producer in South Africa who produces specialized antennas for underground that works with Rajant radios. So there's a big community that we work with to go to market. And we look to appoint resellers and integration partners who can really look after the Rajant brand. And so we take a bit more care about how we appoint those. In terms of the location of our distributors, they're spread across our major geographies. This is, I believe, the latest and up to date. Oh, no, it's not. I beg your pardon. We've just appointed a distributor in Russia covering the Eastern Europe and CIS states. So that's a new market for us that's looking particularly exciting. There are some very significant opportunities out there. In terms of our mesh partners, resellers, they're spread across the globe. We have them in all sorts of different environments, and this is growing. We now have also resellers in Ukraine, in Poland, in Sweden, in Finland. We're just appointing one in Spain, in Morocco. So we're in 59 countries now across the globe and looking to expand into the other GCC states such as Saudi Arabia, maybe do some business in Iraq, perhaps Syria or Lebanon, etc. So our go-to-market strategy is that two-tier indirect channel. Distributors can only sell to authorized Radiant partners, so we will not provide pricing to non-authorized Radiant partners. And in order to give any pricing or indication of our non-public domain information, we always sign an NDA and a partner agreement, we provide training, and we make sure that we do export compliance and vet the geographies and the customers. On the right, you see we do have some direct channels, so defense and military is one of those, and custom products. I can now reveal that the major football league is the NFL. We do pitch side communication for every NFL team. The coaches have secure communications on the sidelines. We weren't allowed to say who that was until the NFL themselves produced a statue of one of their coaches with a Radiant radio on his hip, so it became public knowledge. We did some work with Stanley Black & Decker in terms of a connected construction deal, and although it's misspelt, Northrop Grumman provide one of our military solutions into the US Department of Defense. The channels markets that we go to are these you can see here. So we have over 400 mines globally. We're big in oil and gas, particularly in the States, but increasingly in the Gulf states, in both oil and gas and petrochemical. We have an increasing presence in ports and are deployed in 4 international container ports and currently bidding on 2 or 3 more. We have a relationship with an organization called Wabtec, who are one of the world's largest rail services company. And then we have other business with federal government, with public safety, as you saw, some increasing activity in agriculture, particularly autonomous agriculture and agriculture in controlled environments, utilities, and anywhere where a network needs to be deployed that is reliable, easy to deploy, and supports mission-critical communications. In terms of our partner program, every partner, so we appoint distributors, as I mentioned before. Every partner starts as what we call a Kinetic Mesh associate, and that's the entry level before they're trained. We provide additional benefits as you go through our training program in terms of additional discounts and support for registered dealers. But each of these levels can be explained in detail by either our friends at Minerva, or if you want more details, you can come to myself. There is a partnership brochure available on our website that defines our partner program and how it works. But we're very hands-on at selecting and appointing our resellers because they become the custodian of our brand, and we want to make sure that our end users are fully supported and have a good experience of using Radiant equipment. Because when it is deployed properly with the right configuration in the right environments, there's very little to compete with it in the marketplace. So start as a Kinetic Mesh associate, and then we have 1 or 2 self-maintained users who, due to specialist qualifications, need to maintain the network themselves, but they do have to go through our certification. Then you become a Kinetic Mesh partner once you are fully trained, and then a Kinetic Mesh Premier partner adds an additional layer of discount because you've sold more of our equipment. So there are some revenue goals associated with each level. They're not binding, but we find that it's good to have a target between us that we're aiming at. Otherwise, the product might just conceivably sit on the shelf without any active promotion and involvement. And on the subject of promotion and involvement, we have a marketing program in support of our partners that gives you access to our materials on social media, and the partner portal gives you materials that you can co-brand, imagery for you to develop your web presence, case studies, videos, etc. And of course, a series of webinars similar to this that we've run on specific subjects, and they're all available via the Radiant website. So I've rattled through the presentation, and I hope that you got a sense of Radiant's capabilities, where we position our products, and how we go to market. And that brings me to the point where I open up the floor and we ask if there are any questions. Rohan, do you have any questions through the chat function?
Currently, there are no questions, Chris, in the chat box.
Well, what I will do is I will make available to Rohan this slide deck. It's quite a large deck, but I think it gives you a very good overview of where we operate and how we work. I'm sure he can facilitate that through something like Dropbox or Google Drive, etc. It has my contact details on it. Obviously, you have the contact details of Minerva. And what I would love to see is some offline questions, some interest, some examples of potential opportunities that we can explore together to be able to see if the Rajant solution is appropriate for your environment. Rohan, is everybody on mute or are they self-muted?
Everyone's self-muted.
Okay. So if there are any questions, you can unmute and ask them now. We have about 8 minutes before we're due to finish the call, and I look forward to hearing from you. Okay, Rohan, I'm not getting the sense that there's a huge amount of questions coming through.
No issues, Chris. Thank you so much for this wonderful presentation. Now, once I get the slides from you, I will share it with all the partners. My team will connect with them, as well as we can connect offline over emails if there is any question. So thank you very much, everyone. We have come to the end of the session. The details will be shared with you over email shortly. Thank you. Have a great day, guys.